Can get real today. All right, you guys get this proof done from yesterday? PTSD? No, that can't. You can't get PTSD before you start. No, that's what the P stands for, is post. This would be like pre-traumatic disorder. It does start with a P, so just a different P. All right, so we draw our line, right? Okay. What's a substitution I can make? What do I have in my toolbox right now that I can substitute for anything in here? What did we say yesterday that cosecant equals? R over y. So cosecant squared, instead of r over y, would be r squared over y squared. Yes? All right, so we have that. What about the cotangent squared? So that would be x over y. So that's squared as well. So x squared over y squared. All right. So far, so good. Easy. All we did was two basic substitutions. What do you see? Like when you first look at this, what's the goal here again? To get them now to match. Do I care what they are? No, all I care is that they match each other, right? Now, I look at this and I see one fraction on this side. And I look at this side and I see two fractions, basically, don't I? Well, if I need to get them to match, I either got to figure out a way to get 2 into 1 or 1 into 2. So I do have a way I could put 2 into 1. This is just a subtraction. Can I find a common denominator and subtract those together? All right. What's my common denominator? Y squared. Yes? What's missing out of this fraction? Isn't 1 basically y squared over y squared? So this becomes y squared minus r squared. Does everybody see how I got that? Okay. Well, at least I got it. I'm getting closer. How do I know right now I'm getting closer? They're both over y squared. I've got the denominators done, right? I don't have to do a single more thing with the denominators, I think, because I think I'm done there. They already match. I got it to one fraction. All I got to do is figure out a way to make my numerators match. Do I have something in my toolbox that I could use? Like, do I know what r squared equals? X squared plus y squared. So I can make a substitution right here and say I have y squared minus, but instead of r squared, I'm going to replace that r squared. And yes, I need to use parentheses because of the whole minus. I got to distribute the negative there. Instead of r squared, I'm going to replace that with x squared plus y squared. Does that make sense? Well, combine like terms. What do I have? What happens to my y squareds? My y squareds now cancel out, and all I have left is negative x squared over y squared. And yep, they match. You don't have to circle them as long as they match. Now, is this the one and only trig proof of this that we need? No. Like, there's lots of different ways to prove things. Now, I want to go back to our toolbox right now. I want to talk about our toolbox, and I want to talk about why I call it a toolbox. We said sine is equal to y over r. We had cosine is equal to x over r. We had tangent is y over x. We had the reciprocal ones too. We also had x squared plus y squared equals r squared, right? These are the only tools we really have in our toolbox, right? Now, I want you to think of these as our hand tools. I got screwdrivers, hammers. That's really all I got, right? Can I build a house with screwdrivers and hammers? You can. I mean, they did it for hundreds of years. But there's way better ways to do things now, right? And it's going to take me forever with basic hand tools, right? But even with basic hand tools, take a flathead screwdriver, right? What's a flathead screwdriver designed to do? Turn a flathead screw. Now, if you're good with your tools, can you use that flathead screwdriver to do other jobs? Can you manipulate that screwdriver to do other things? Sure. You can use it as a chisel if you had to. You could use it as a hammer if you were in a pinch. Like, there's lots of things you can do with it, right? Heck, you use it to start I've seen a friend of mine start his truck with a flathead screwdriver. Like, there's lots of things you can do if you want to manipulate it, right? Now, here's what I'm going to ask you to do with all the tools in our toolbox. Not just these, but eventually that box on page 133 is also going to be our toolbox. Those are our power tools. Right now we're using hand tools. We're going to prove our power tools, and once I prove those and once I learn how to use those, I'd rather use the power saw than this one. We'll call this the hand saw, right? But even with the hand saw, if you know this hand saw only in this form, you can use it, but you can only use it sparingly. Would you agree that this is the same thing as x squared equals r squared minus y squared? Are those two equations the same equation? Is it the same thing as y squared is equal to r squared minus x squared? Is it the same thing as x squared minus r squared is equal to negative y squared? Is it the same thing as y squared minus r squared would equal negative x squared? Are all these different equations the same basic equation, just manipulated? Instead of having one tool in my toolbox, I now have 1, 2, 3, 4, 5. What that means is, yes, in this form, if I ever see an r squared, yes, I can replace it with an x squared plus y squared, right? Did I use that in this proof that we just did? Yeah. I had an r squared. I replaced it with an x squared plus y squared, right? But if I would have had in my toolbox, which one was it? X squared minus r squared, right? If I would have had that one, instead of being on the lookout for just r squared, I could have been on the lookout for x squared minus r squared, couldn't I? Did I have that in my proof? I could have, right from here, I have y squared minus r squared. I could have substituted that whole numerator for what? For negative x squared. So basically what I'm going to ask you to do is not just learn that toolbox one way. We want to be able to take every tool in our toolbox, every basic tool, learn it the main way. Yes, we have to know it that way. But if you know it more than one way, it just makes your life easier. Because now I can be on the lookout for more things to make other substitutions. Do you see how that could be useful? It's going to save you work in the end, okay? So, I want you, everybody look at page 133. I want you to open up and look at that toolbox. Let's just take the very, very first reciprocal identity, which is cosecant is equal to 1 over sine. This is absolutely going to be one of the identities you are going to use. Huge. if you ever see a cosecant, you're going to want to, you can replace that with 1 over sine if you want to. Whenever I say in this next few sections, if you ever see this, you can substitute with this, it's always if you want to. Is there ever going to be a thing that you have to do it this way? No. Guys, this section these sections over more than any other section, whenever you ask me to do a question for you, the first thing I'm going to ask you is, what do you see? Because I don't want to do them my way. Because you're not going to do them my way. You're going to do them whatever you see. I want to go down your rabbit holes. I want to go down the path that you see. Because maybe we'll be able to get there that way. Hopefully we can. Sometime, and we're going to go that way. You're going to see me do proofs. And we might get 7 and 8 rows deep, and I'm going to go, yeah, we're just not getting anywhere this way. Why don't we try it my way? And I'm going to erase all of that. And you're going to go, really? I got to start over? Yeah. Sometimes that's going to happen to you. You're going to get 7 or 8 proofs or steps down and go, this just isn't getting closer. This just isn't going where I want it to go. Let me either go back to the beginning or let me just get rid of the last 4 steps and go back to here, and maybe there's a different path I could have chosen. Okay? Like that's going to happen to every single one of you through this process. It's going to happen. We're going to do it as a class, not because maybe I made a mistake or you made a mistake. We just tried to go down a rabbit hole and see what happens. Sometimes it works and it leads to the end, and sometimes it's just we end up right back to where we started, and it just doesn't get us where we want to go. So that's going to happen. Don't be afraid of that. But also, whenever I say it's a substitution you can make, that's exactly what I mean. If you ever come across a cosecant, if you want to, you can change it to 1 over sine. And vice versa. If you see a 1 over sine, if you want to, you can change it to cosecant. What would be another thing I could be on the lookout for, though? What's another way I could manipulate this equation so that I could be on the lookout for more things? What would I get if I butterflied that? Let's butterfly it. Wouldn't it be cosecant times sine equals 1? So here's one thing I can be on the lookout for. I can replace it with that. Here's something I can be on the lookout for. I can replace it with that. Here's something I can be on the lookout for. If I ever see a cosecant times a sine, bam, I can change that right to a 1. Like that's just gone. It's a 1, right? And likewise, it's probably not going to happen. If I ever see a 1, if I wanted to, I could turn it into a cosecant times a sine. That's probably not going to be a very useful one, but definitely going that way, right? Anything else I could do? Any other ways I could manipulate this? Say that one more time.
You could make both sides negative.
Okay, I could make both sides negative. I could put a negative here and a negative there. How about sine could equal 1 over cosecant. If I ever see a 1 over cosecant, I can replace that immediately with a sine. Basically what I'm doing is I'm taking one tool and I'm turning it into 3. Does that make sense? I don't just want to use my power saw to cut boards. What's another thing I could use a power saw for? What's a weird job you ever use a power saw to do?
I've seen people use a circular saw and a rake on a roof.
Okay.
To make it straight.
You could do that. You could cut a pipe with it. Probably not a great idea, but that's basically the same idea of what we're doing here, right? I've actually used it to like dado out something too. Like you just kind of run the table. So it's not safe. You probably should never do that. But you get the idea of what the goal here is. We are going to do proofs where, yes, right now all the proofs we're doing, the only tools we have in our toolbox are X, Y's, and R's. Like this is a trig proof, but our toolbox is very limited. We are not going to use X, Y's, and R's very often. This actual homework assignment I'm going to give you today is the one and only homework assignment you're going to use X, Y's, and R's. Because right now this is all we have in our toolbox. We're proving our big tools. Our big tools are the ones on page 133. And those are, what are your reciprocal identities? You've got cosecant equals 1 over sine. You've got secant equals 1 over cosine. You've got cotangent equals 1 over tangent. Now, why did they not keep this list going and say that sine is equal to 1 over cosecant? Because that is an absolute fact. Huh? It's already right here. This is that, just manipulated, right? So we already have that written right here. There's no reason, it just becomes redundant at that point. We've already got it there. Does that make sense? So we don't have to write that again because we already wrote it. Okay, so we have those three. Those three, I am going to need you to memorize. You probably already have them memorized, right? Great. There's some new ones. And I will say, you better know these. Tangent is equal to sine over cosine. And cotangent is then going to equal cosine over sine. I will tell you, you're going to use these two identities a lot. Absolute a lot. Now, I want to talk about that tangent equals sine over cosine for a second. Again, that's one identity. If you ever see a tangent, you're going to change it to a sine over cosine. That's one of your options. It's not the only option. It's always an option you can go in. So if you were in the middle of a trig proof, just with what I have written on the board, if I had a tangent in a proof, stop doing that, board. What is something that I could change that into? I could change it into sine over cosine, if it fits my needs. I could also, using this identity, if I manipulate this identity, this is a tool in my toolbox, to make it say tangent, what would the other side equal? 1 over cotangent. These are two different substitutions. I could go down this rabbit hole if I want to. I could also go down this rabbit hole if I want to. Who's going to make that decision? You are. It's just different options of where I can go with it. Does that make sense? And again, I'm just manipulating these same things. So let's do that. Let's do that with this one. How can I manipulate this tool and turn it into multiple tools? What's another form of this tool? All right, cosine could equal sine over tangent. Great. If I ever see a sine over tangent, that's a cosine if I want to. Or vice versa. If I see a cosine, I can use it into that. What's another thing I could do? Sine will equal cosine times a tangent, right? So if I ever see a cosine times tangent or a tangent times cosine, because that's, commutative property basically, right? How about, let's do this. Owen, will you do me a favor? Will you walk back to my desk? Do you see my mass shield hanging there? Can you pick that up? All right, the sign behind it, can you explain that joke to me now? Can you explain that joke to me now? Because basically, that joke says, if I have the sine of b divided by the tangent of b, it has to equal cos b. Ha 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 ha. Yeah. Huh? I know, you don't. It's Bill Cosby. He's a rapist and all that now, so we don't need to talk about him. But all that is this identity, okay? So again, with this, all it's doing is increasing our toolbox into what can I be on the lookout for. Does that make sense? And yeah, there's more. I mean, I could keep going and change this into 1 over tangent, and basically, if I flip this side, I can flip this side over here. But to me, that one is actually a more closely related, because what is 1 over tangent? That's cotangent, right? To me, that's actually closer to this identity than that identity. But you get the idea. You can open that door, and it gives you more and more things that you can make substitutions with. Can I survive this chapter without knowing these? Yes. Yes, you can. Basically, what I'm saying is like the proof that we did to start today. I used x squared plus y squared equals r squared, didn't I? Could I have made my life a little bit easier if I would have known that I could take this and say that's the same thing as y squared minus r squared equals negative x squared, and I could have right from here just taken this whole numerator, and instead of making this substitution, I could have just went, you know what, that whole thing, that's just r squared. What am I basically doing with those other ways of using this? I'm making my life a little easier, aren't I? It's just like anything else. The more knowledge you have, the more tools you have in your toolbox, the easier your life gets, right? You can build a house with a hammer and some screwdrivers, but your life is going to be really hard. It's going to take a while, and you're going to have to do things in some weird ways. If you have better tools and more tools in your toolbox, all of a sudden your life just gets easier, right? So, all right, everybody look at page 133. I want you to look at the practice exercise at the bottom. This idea right here of being able to take one of these identities and write it in multiple ways, that's what you're doing. So number one, well, we already did number one. Let's do number two. Number two says what? Cosecant, or was it secant? 1 over cosecant. Great. Or 1 over cosine. Yeah. All right. That's one way to use that identity. What's another one? Manipulate that. Cotime times secant would equal 1. Okay? Can I manipulate it again? Cosine would equal 1 over secant. Great. That's all I want you to do. That's all you're doing. This isn't a trig proof. This is, can I take my 1 tool and turn it into 3? Okay? That whole section, that's all you're doing. You'll notice every single problem in that section is one of your tools in your toolbox, right? Yes, we're going to memorize the simple fact that sine squared plus cosine squared equals 1. Like, that is an absolute fact of life. And if you can be on the lookout for this, it'll equal 1, and 1 is equal to that. But can I use that same thing in other ways? What does sine squared just equal? 1 minus cosine squared. And likewise, cosine squared equals 1 minus sine squared. That's 3 different tools I can now be on the lookout for. If I ever see this, great, I can turn it into a 1. If I ever see a 1 minus cosine squared, I can change it into a sine squared. And a 1 minus sine squared, I can turn it into a cosine squared. I'll tell you right now, these 3, yeah, you'd better know those. Okay? That's one of your Pythagorean identities. All right, so are we good with 1 through 8? Actually, 1 through 7. Yes? All right, the rest of these, you are going to do some actual little proofs. Let's. Number 8, I kind of want you to use x, y's, and r's to do that one. Now I want you to look at number 9. Flip over to number 9. Now, here you're going to have to bring back the table in your brain. Think table, table, table. 1 plus cotangent squared of 30 degrees is supposed to equal cosecant squared of 30 degrees. This one we're going to do a proof with numbers. I want you to think of your table. Do you remember what tangent of 30 degrees is? Square root of 3 over 3. So what's the reciprocal of that? What's cotangent of 30 going to be? Square root of 3. Right? Great. What's square root of 3 squared? 3 plus 1. I better get 4 over here. All right. What's cosecant of 30? Stop doing that. Come on. I got faith in you. There you go. Okay. What's sine of 30? What's sine of 30? It's the first one. Sine of 30. 1/2. What's the reciprocal of that? Woohoo! And by the way, when you do some of these proofs, you're going to go woohoo all the time. Because you're just going to be like, dude, it worked. It's like hard. You'll get it to work. I'm not kidding. I'm really, really hoping when I give this test, I'm just in the back like grading papers or whatever while you guys are testing, and you're going, woo, 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 woo. Like, it'd be kind of fun. All right, so those, yes, you got to use your table for those, and those are all proofs with numbers. Are we okay with those? You have to use your table. When you get to 19, those are all x, y, r proofs, just like we started that first one. You're just going to use x's and y's, use substitutions there. We're not making substitutions with any of these yet. We're going to get to those tomorrow, or Tuesday, okay? Are we feeling okay with these? I mean, you got to kind of try them before we. All right, so